Okay, this is 5.3, solving systems of linear equations by elimination. And I just want to point us out up here to something that we have been doing all year long. But we just need to keep this in mind about change in values. Sammy, what's 6 plus 8? 6 plus 8. 6 plus 8. Put in your calculator. If we're not going to do it in our head, that's fine. What is 6 plus 8? Perfecto. 14, and then 7 plus 4 would give me, no. 7 plus 4 is 11. Watch what happens here. If I multiply both of these equations by 2, meaning, you did, dude, you did. If I multiply 6 by 2 times 2 times 2, that gives me 12 plus 16, which gives me what? What's 12 plus 16? No. 28. Look at this right here. This is double, right? Everything is just doubled. Couldn't I divide everything back by 2 and get with what I started with? Yeah. Did I change the value of anything then? Not really, because if I can multiply by something and then divide back through, it's going to be the same. Look at if I compare this system right here. Let's say I take this answer to this answer and just write it as a ratio, 14/11. If I multiply this next equation by 2, that's 14 plus 8. Somebody already said it. It's 22. Look at this ratio here. 28 to 22. What in the world do you think 28 over 22 reduces to? 14 over 11, right? Because I just divide it in half. So do I really change the value? Isn't 28 22nds the same as 14/11? Yes. It is. So I don't really change the value of it. This is going to be important. If I multiply everything in an equation by the same number, I do not change the value of it. Sure, it gets bigger, but I can always undo that by dividing back through it. What if I multiplied everything by a -2? Do you think that's going to make a difference? Yes. It's going to make a difference in the numbers I get, but I don't know about that ratio that I'm looking for. This would be -12 minus 16 would give me a -28. If I did by -2 here, it would be -14, subtract 8, that would give me a -22. What's a negative divided by a negative? It's a positive, right? It's still 28 22nds, which still reduces to this. Point being, we can multiply equations by anything we want, as long as we do it to every single term in it. Every x term, every y term, every constant term. And the value does not change. Soon as I don't multiply this by the same, I won't get that though. You got to multiply everything. Here's how elimination works. If I gave this to you before, would you want to graph this? Well, to graph, what would I have to do? Get it to look like y equals mx plus b. Get out a piece of graph paper, get a ruler out, identify my slope, identify my y-intercept, accurately graph, get the intersection, get the correct x-y ordinate pair. Labor intensive. In order to use substitution, I could solve for y in either one of these and substitute it in for the other. This is what elimination is, though. First thing you want to look for, what you're really going to do is add these two equations together. I want to look. Since I'm adding, I want my like terms to be lined up. Are my x's lined up, my y's, and my constants?
Yes.
They are. That's the first thing I'm going to look for. Second thing I'm going to look for is I want one of these variables to eliminate. Elimination. 7x minus x is 0, right? Looking at these two equations, if I added those two equations together, which of those variables would eliminate or go away? If I add straight down. Look right here.
Also, can you repeat yourself?
If I add these two equations together,
Yeah.
the question was which of these variables are going to eliminate?
All of them.
Not all of them.
Not the one on the right.
Okay, here we are. And Luke says the one on the right. Why did you say the one on the right?
4 minus 0 is 4.
Well, yes, but I'm looking to eliminate a variable.
Well, you can get rid of y.
Y is going to go away. What I want us to point out to is what do I notice about the signs? One's positive, one's negative. That is going to be a key. I want to look, after I line these equations up, do I have coefficients or numbers in front of the variable that are the same? I certainly do for x, and I certainly do for y. The next thing I am going to look for, do I have signs that are opposite with those same coefficients? I certainly do. The y and the y, if I add those together, they will go away. I'm going to make a little addition problem here. These are lined up, and I've decided that if I add down, this is going to eliminate. What is 2x plus 2x?
4x.
4x. A positive y, subtract y. 1y minus y, those eliminate. That's what we want. That is going to equal 4. 4 times what number gives me 4? Or if I divide both sides by 4, that goes away. 4 divided by 4 is 1. Look at that. How much work did I have to get an x coordinate compared to substitution? Not very much. Remember last week with substitution? That step 2 was a whole bunch of steps. I've already got what x equals. The way you find y is going to be the exact same way we found y with substitution. I'm going to plug it into either one of the equations. From this point here, I want to check this out. Which equation do you think is easier to plug it into? Why? Because the y is positive. And I'm going to choose that as well because I need to solve for y. So this x will go right there for that x. I can use either equation. This becomes 2x, which x is now 1, plus y is equal to 4. 2 times 1, 2, plus y is equal to 4. This equation right here can cause some issues sometimes. It shouldn't though. 2 plus what number gives me 4? 2 plus 2 would give me 4, but this is a positive 2. So in order to solve, I would subtract 2, and lo and behold, that eliminates. Y is equal to 4 minus 2. It's 2. I write it as an ordered pair. The ordered pair, 1, 2. You can test this. 2 times 1 is 2, plus 2 is 4. 2 times 1 is 2, minus 2. 2 minus 2 is 0. It checks. I box it in. A little bit easier than substitution, yes? I agree. Next example. Are the variables lined up? I got x's, I got y's, and I got constants. Do you see something's the same? I do. 3 and 3, and negative 1 and 1. I want one of these to eliminate. Look what has the same coefficient and opposite signs. The y's will go away. This is ready to add down. I'm going to add these two equations together. 3x plus 3x. 6x. This eliminates. That's what I want. 4 plus 2. 6. Divide both sides by 6. X is equal to 1. You have one piece of what you need already.
Yeah, that part is easy, but
It is.
the
Now,
second part,
which equation do you want to use? Doesn't matter which one we use.
the second one.
I'm going to use the second one as well because I want to solve for y, and this y is already positive. So I'm already thinking if I put it in here, I'll just have to subtract 3 and then I'll have my y. I'm going to take this and I'm going to put it in right there for that x. That means this equation becomes 3 times 1 plus y is equal to 2. 3 plus y is equal to 2. Solve for y. Y is being added by 3. That's a positive 3. In order to move it over, I subtract 3. Y then would equal 2 minus 3 is
Wait.
negative 1.
Hold on.
You have an x and you have a y. I write it as an ordered pair. 1, negative 1 is my solution. And I could certainly plug this back in. What's 3 minus 1? 2. 3 minus minus 1, 3 plus 1 gives me 4. It certainly checks. Those are the type of problems you're going to see very few of that line up like that. At the minimum, we're going to have to line them up. Very few of them are going to be set up totally like this. But once we have them lined up, then I can decide which one I want to do. Let's look at this next example here. And here's where it amps up a little bit. You're going to follow the same process though. Are your x's and your y's lined up?
No. Well, yes.
They are. Do you see any coefficients that are the same?
No.
No. Do you see any signs that are opposite?
Yeah.
I don't. This is positive.
Yeah.
This is positive. I don't see any variables
That are the same.
that have the same coefficient and then they would subtract right away, right? Like in these two.
Yeah, but it's the same time.
They are the same signs, but in order to use elimination, I need to have opposite signs. We need to start thinking back to what we did right up here. I'm going to want to multiply one of these equations, maybe both of the equations, by a number, because I know if I multiply every term in an equation by the same thing, I'm not going to change the value of it. It's going to make it different, but the value is going to be the same. And I want one of these to eliminate. What should I choose? In order for my x's to go away, what would this top one have to be? Just what coefficient in front of the x would this have to be in order for my x's to eliminate? They need to be the same number with opposite signs. So in order for x's to eliminate, this would have to be a negative 6. In order for the y's to eliminate, y's, this would have to be a negative 3. Does it matter which one I choose to work with?
No.
No. What do you want to choose to work with?
Maybe. They're both easy.
What do you want to eliminate, the x's or the y's?
X.
Let's eliminate the x's. If I want this top one now, if this is positive 6x and I want this to be negative 6x, what do I have to multiply 3 by to make it a negative 6?
Negative 2.
Negative 2. That's what I want to do. I want to multiply excuse me, this whole equation by negative 2. And by multiplying every single term by negative 2, I do not change the value. Here's what we have to be careful with. This negative 2 gets distributed to everything in there. Notice, I put this parenthesis around the back. Here's what we tend to do, and I do it too. Negative 2 times a positive 3x. Negative 6x, that's what we want. Negative 2 times a 1y would be negative 2y. And here's the part we sometimes forget, and I forget this as well. We'll do this and this, but we'll forget to multiply this 11 by negative 2. You have to multiply everything by the same thing, and then I don't change the value of it. And you can certainly divide everything by negative 2 to see if you get what you started with. That would be 11, that would be a positive 1, and that would be a positive 3, dividing everything by negative 2. I haven't done anything except manipulated this equation to make it work for me by multiplying it by the same number. My bottom equation would stay the same. I don't need to touch that. Now I can see I'm ready to add down. What's going to eliminate? The x's. Negative 6 plus 6. 0. Eliminate. Negative 2y plus a 3y. Positive 1y. Negative 22 plus 24. Positive 2. That means y is equal to 2. And again, when you look at complexity-wise, this is not very complex compared to solving for y, substituting it in. The amount of work is much less. Now that I have one of the variables, I need to take that y and plug it into either one of these original equations. I don't want to go here, so it's going to make it messier. I want to go back to either one of these. Now, if I already have y, I'm looking to solve for x. Both of these are the same. Doesn't really matter where I put it in. They're both positive. Let's put it into the first equation this time. It's 3x plus y is equal to 11, and I'm going to take this y and substitute it in right there to solve for x. That means 3x plus y, but y is 2, is equal to 11. I now have a two-step equation to solve. Subtract 2, subtract 2. 3x stays. That goes away. 11 minus 2. 9. 3 times what number gives me 9?
3.
Divide both sides by 3. X would equal 3. You have the two pieces of the puzzle you need. You have the ordered pair, 3, 2. And I can certainly test these. If x is 3, y is 2. 9 plus 2 is 11. 18 plus 6 is 24. It definitely works. I box it in. Just like that. Questions? We're going to flip it. Oh, Nelly. Now, if I look at this example here, what's wrong with the way this is starting out? To do elimination. Landon?
The X's aren't together.
We're not lined up, for sure. If I look at this, though, wouldn't this lend itself nicely to substitution? I could take this whole thing and plug it in right here for y, but we're not doing it. I'm going to try to use elimination first by lining these up, which means I'm going to put my x's and my y's on one side, which means what? This 5x has got to come over here, which means I can add 5x to both sides. I'm going to write this equation up here. 5y is equal to 15 minus 5x. In order to get this over there, I use inverse operations. I would add 5x. This equation becomes then 5x, I'm going to write my x first, plus 5y is equal to 15. And again, all I did was manipulate the equation to start lining it up. On this one, I'm going to do the same thing. I would add 2x to both sides. This is y is equal to negative 2x plus 3. And right now I'm doing nothing except rearranging. That leaves me with a 2x plus y is equal to 3. That's the first thing I have to do. Now it's lined up. Now I'm looking to use elimination because we are in elimination. And again, like I said, if I was given the choice, I may have chosen that one to do solving by substitution. But I'm not going to do it. I'm going to always go to elimination. Do you have any coefficients that are the same? 5 and 2, they ain't the same. 5 and 1, they ain't the same. Do I have any signs that are opposite? No, they're both positive. What would be the easiest thing to eliminate on this one? And what would you do?
X.
Is there anything I can multiply 2 by to get 5?
No.
I could, right? I could multiply by 5 halves. I could multiply by 2.5. That would give me 5. Do you want to really work with decimals, though?
No.
I'm going to tell you you don't, and you don't want to work with fractions. If this is 5 and this is... Yes. If this was a negative 5 right here, wouldn't those go away? So I'm already thinking easily, if I multiplied this bottom equation by a negative 5, that's going to eliminate my y's. I'm going to do that. I'm going to take this whole thing and multiply it by a negative 5. My top equation would stay the same. 5x plus 5y is equal to 15. Negative 5 times positive 2. Negative 10x. A potential for a mistake there because it's a negative times a positive. Negative 5 times 1y. Well, that's negative 5y. That's why we did by negative 5. That's what I want. Is going to equal negative 5 times 3, which is negative 15. I now can add down. What is 5 subtract 10? 5x minus 10x. 5 minus 10. Negative 5x. That eliminates. What is 15 minus 15? 0. This is pointless because I know x has to be 0. I take that 0, plug it in there for x. Y then is equal to negative 2 times 0 plus 3. Y is equal to, that would go away, 3. I have the ordered pair 0, 3. Does it work? Well, if x is 0 here, that would go away. Y would certainly equal 3. If I look at the top equation, if this x is 0, this would go away. What's 3 times 5? 15. Does 15 equal 15?
Yes.
It does. I'll box it in. Last one of the day. Are they lined up?
No.
No. What has to happen? This has to come over. This has to come over.
Yes.
Right? I'm okay if you guys just start moving this over. But if I move this over to the other side, what happens to its sign? It changes, right? Because I would want to subtract 4y from both sides. So this top equation, just rewritten, is 5x minus 4y is equal to 8. This one I would subtract 3x from both sides. Minus 3x plus 3y is equal to negative 3. Haven't done anything yet except rearrange them and line them up, so now I can start the investigation of what do I want to eliminate and how can I get this to eliminate. Okay, I'm going to go through my thought process again. My x's and y's and constants are lined up. Do I see coefficients that are the same? No, that's a 5, that's a 3, that's a negative 4, that's a positive 3. So the next thing I'm looking for is opposite signs. I have opposite signs here and opposite signs here. All that tells me is what? I ain't going to have to multiply by negative, right? Because my signs are already opposite. I can choose with what I want to work with. Is there an easy way to get from 3 to 5?
2.
Well, you could multiply by a fraction, couldn't you?
Yeah, but
We don't want to do that. We want to think about this like a common denominator. What would be the common denominator, because I want these to be the same between 5 and 3?
oh, hold on. Oh, boy. I can't find them.
Well, if I want a common denominator, like we did earlier, between
Yeah.
a third and a half, couldn't I take 3 times 2 and I know that's going to be a potential common denominator?
We can make the common denominator 2. Hold up. Because, yeah, 5 and 20, 3 and 12.
You're thinking too hard, dude. Thinking too hard. Think of this just like this common denominator. If I wanted to know what the common denominator between a fifth and a third is, what would you tell me it is?
There is none.
There is one.
It's a 5 and a 3. I don't see it.
The common denominator, though.
The what? I don't see. No, they're not the same.
How would I get a common denominator between 5 and 3?
Oh, you 15.
There you go. I know. I told you he's overthinking it. Quit overthinking.
Just his reaction when he realized what he did. Like,
So wouldn't it be nice if this was a 15 and this was a negative 15?
Yes.
Or this could be a negative 12 and this could be a positive 12. Right? I'm just taking the coefficients and multiplying them together. That will always work. Just like it always does with the common denominator. I'm going to choose to work with the x's here. And I'm going to make these x's eliminate. And I just said 5 times 3 is 15. Which means I would multiply the top by 3 and the bottom by 5. You're just multiplying by the opposite, just like you would with a common denominator. And yes, that's perfectly legal to do both of those. You need to distribute to both now. 3 times 5x, 15x. 3 times negative 4, negative 12y. 3 times 8 is equal to 24. I just multiplied this equation by 3. Haven't changed the value of it because I can divide everything by 3 and get exactly what I started with. I do the same down here. Negative 15x. 5 times 3. Positive 15y. 5 times negative 3. Negative 15. And again, I'm double checking to make sure I distributed all of those, which I did. And now I can see I have same coefficient, opposite sides, which is going to allow me to add down and eliminate. 15x minus 15x, eliminated. That's what we want. Negative 12 plus 15. 3y. 28 minus 15. 13.
Now we do the
Divide by 3.
Divide by 3.
Y is equal to 13/3. I will take that Y and plug it in right there to the original. 3 times Y, but Y is now 13/3, is equal to 3x minus 3. These 3 divide into each other, or it's 39/3. 13 is equal to 3x minus 3. I would add 3. 16 is equal to 3x. I would divide by 3. X is equal to 16/3. And I got it. 16/3, 13/3, and I'm good to go. And you could certainly check those by putting them back in. Yes, you will get some fractions. The main thing that I want to point out on this one is how we get from here, these equations right here, over to here. Looking at my variables, seeing what signs are opposite, and then doing it.